Okay, for part 2 of the video, we're going to be continuing on, but what we've done so far is I've demonstrated how to do converting from vertex form to standard form and how to convert from standard form back to vertex form. We're going to show you the other two conversions that we'll do, converting from standard to factored and factored to standard. You're going to find those pretty straightforward. It's based on things you've done before. And then we're going to talk a bit about the features of each of these type of equations. So let's move on here. We're now going to convert from standard down to factored form. Okay, so let's write one up here. Y equals x squared minus, let's say, 3x and then minus 28. Okay. So what I'm going to do is exactly what we've done before. We've done this for a while, where you say, look, I know how to write this thing out so that it's in a form like this. Each of these is going to be x because we have to get x squared. I'm going to take 28 and write all of the factor pairs that make it up there. So 2 and 14 and 4 and 7. And I'm going to look for a pair that subtracts to get 3. Well, that'll be 4 and 7 right there. So we'll put a 4 and a 7. And these have to add together to get negative 3. The only way for that to happen is if these are positive 4 and negative 7. So when I FOIL, I get x squared minus 7x plus 4x is negative 3x, and then minus 28. And now we're done. We've gone from standard form to factored form. Okay? So that was pretty straightforward. Let me do this, create a little bit of room here for us. And just write factored right here. Okay, well, you can imagine that going from factored form back to standard form, all we have to do is just refoil a thing. So x squared minus 7x plus 4x, so there's our minus 3x again, and then minus 28, and we're back to standard form. So standard to vertex is really pretty easy. I'm sorry, standard to factored is pretty easy, and then factored back to standard is just as easy. We've done those skills for quite a long time. So that's going to take a little worry off our plate. The other one, the going from vertex to standard and standard to vertex, took a little bit more work, but you'll get used to that as well. Okay. So now let's take a look at some of the features of each of these types of equations. Okay. To do that, I want to pull up Desmos, and I want to point out over here, first of all, I've got 3 different equations written up here. This one is in vertex form. This one is in factored form. It's got a 3 out front, but that's okay. And this one is in standard form. Okay, and what I want to do is look at each of these equations and look at various features that we can see based on those equations. I'm going to turn this one on first, and I want you to notice a couple things. First of all, let's take a look at the vertex right here. I'm going to label that point here right at 3, negative 4. Okay, so you can see it right there. And you can see that that matches up with this number right here and that number right there. And you may remember that in the general form, the h was the x-coordinate of the vertex, and k was the y-coordinate. Notice it's x minus h, and so x minus, in this case, 3 means the x-coordinate's at 3, and then plus the y-coordinate of negative 4. Okay? So the reason we call it vertex form is you can read the vertex right off it. Now I want you to notice something. If this minus was actually a plus, look what happens to it. Now the x-coordinate is at negative 3. And the reason is that plus could have been written as minus a negative 3. Okay, so plus is the same thing as minus a negative. And so you can still see it's x minus the x-coordinate of the vertex. Okay. So the vertex can be read right off of that easily. Okay. And then we'll talk a little bit about this this 2 in just a little bit. Okay. So let's turn that one off. Get rid of that point there, and turn that one off. Turn this one on. Okay. this one is showing up down here, and I want you to notice you can't tell where the vertex is. Well, you can on the graph. It's at 1, -12, but nothing in the equation tells me that. Okay? But there are some things that this tells me, a couple things. I want you to notice where this equation crosses the x-axis. Here's the x-axis right here, and it crosses at -1, -1, 0, and at 3, 0. Okay. Well, notice that those numbers are essentially appearing right here. Here's an x minus 3, and it's crossing right here at 3. You might remember from our work with working with factored forms there, when y became 0, that happened because I put a 3 in right here. So if I put a 3 in for x, then y became 0 right here. I got that point right there. Okay. Also, when x becomes -1, this becomes 0, making the whole thing 0. So you can read the x-intercepts or the roots right off of the equation when it's in factored form. You can't tell that information from vertex form, but you can tell the vertex. On this one, in factored form, you can read the x-intercepts right off of there. Okay, so that's the feature of the factored form. Again, we'll talk about the number out in front in just a little bit. Okay, so let's turn that off and take a look at the last one here. Here's one in standard form. You can't tell where the roots are, or the x-intercepts. You can't tell where the vertex is. Not much else, but you can tell this point right here, 0, 2. Okay, right there on the y-axis, called the y-intercept, and you can read that right off of here. And the reason is, if you put a 0 in for x right there and right there, then these two terms, the 2x squared and the minus 5x, all become 0. And so your remaining number is simply 2. So the feature about the standard form is you can tell what the y-intercept is. So I want to go back to a feature about vertex forms. Let me turn this off and turn this one back on. I want you to notice that you can imagine a line going right up through the middle of this parabola. Okay, right there, up through the middle. In fact, I'll label it x equals 3. Okay, and maybe I'll turn it into a dashed line because we're just kind of imagining it there. Okay, that line, we call it the line of symmetry because the parabola is symmetric on both sides of that. Okay, it cuts it right in half. Okay, so that is called the line of symmetry right through there. Okay, the nice thing is you can tell right where the line of symmetry is because you know where the x-coordinate of the vertex is, right here at 3. Okay, so since it goes right through the vertex, the line of symmetry always has the same number as what we got from right here. Okay, so that's a lot of the things we've talked about, and there's only one more thing I want to show you about these things, and that is, what does this number 2 do out front here, or this 3, or that 2 right there? Okay, so to look at that, I want to look at a plain old parabola, y equals x squared. Okay, plain Jane parabola. Let me just make it black. Okay. So I want you to notice something about that parabola. Its vertex is right there at the origin, 0, 0. And I want you to notice that when you go to the left or to the right, it jumps up by 1. In fact, I'll label those points there. It's going to be at -1, 1, and at 1, 1. Okay? When you jump from the vertex, you go from the vertex, you jump up by 1, okay, each time. Well, on this parabola right here, if you go from the vertex and go over 1, you actually go up 2 right there and 2 right there. That corresponds with this number. Okay, so let me turn off those points, turn off this, and just point out that for this equation, it jumps up by 2 if you step to the left or to the right of the vertex. You might be thinking then that this one jumps up by 3. Let's take a look. Okay. And you go at the vertex is right here. If you step to the right, you go up 3. If you step to the left, you go up 3. So this number here out in front also tells you what I might call the first jump. Okay? Now,
all of this information is summarized in the notes that I published for you as well. Okay? But I wanted you to be able to see them live so you can see what's going on. So you've now seen how do you convert back and forth between vertex to standard and standard to vertex, and factored to standard and standard to factored. Okay? In fact, let me go back to the diagram on that. If you were going to convert from vertex to factored, what you would do is go to vertex to standard and then to factored. Okay? Or if you're going to convert from factored to vertex, you'd go to standard and then back to here. Okay? So you've now seen how to do those conversions, and you've seen some features about that. And again, those are all summarized in the notes that I put together for you.